Probability is a measure of the likelihood or chance that a specific event or outcome will occur, expressed as a number between 0 and 1. A probability of 0 means that the event is impossible, while a probability of 1 means that the event is certain. In between, probabilities range from very unlikely close to 0 to very likely close to 1. Probabilities can be estimated based on prior knowledge, experience, or data analysis. Keywords and terminology. Event. An event is a set of outcomes of an experiment. For example, if you roll a die, the event of getting an even number consists of the outcomes 2, 4, and 6. Sample space. The sample space is the set of all possible outcomes of an experiment. For example, if you flip a coin, the sample space consists of the outcomes heads and tails. Probability distribution. A probability distribution is a function that assigns probabilities to each possible outcome of an experiment. For example, the probability distribution of rolling a dice is uniform, meaning that each outcome, which is 1, 2, 3, 4, 5, or 6, has an equal probability of 1 over 6. Random variable. A random variable is a variable that takes on different values depending on the outcomes of a random event. For example, if you roll a die, the number you roll is a random variable. Expected value. The expected value of a random variable is the average value it would take over an infinite number of trials. For example, the expected value of rolling a die is 1 plus 2 plus 3 plus 4 plus 5 plus 6 over 6 equals 3.5. Conditional probability. Conditional probability is the probability of an event occurring given that another event has occurred. For example, the probability of rolling a 3 given that you rolled an odd number is 1 over 3 because there are 3 odd numbers 1, 3 and 5 and only one of them is a 3. Bayes theorem. Bayes theorem is a formula for calculating conditional probabilities. It states that the probability of an event A given an event B is equal to the probability of event B given event A times the probability of event A divided by the probability of event B. Basic formulas. The formula for calculating probability depends on the type of situation you are dealing with. Here are some common formulas. Probability of a simple event. For a simple event with only 2 possible outcomes, for example, for flipping a coin, the probability of one outcome is, probability will be number of favorable outcomes over total number of possible outcomes. For example, the probability of getting a head when flipping a fair coin is 1 over 2 because there is one favorable outcome which is getting a head out of 2 possible outcomes, getting a head or getting a tail. Probability of a compound event. For a compound event with more than one possible outcome, rolling a die and getting an even number, the probability is number of favorable outcomes over total number of possible outcomes. For example, the probability of rolling a dice and getting an even number is 3/6 or 1/2 because there are 3 favorable outcomes, getting a 2, 4 or 6 out of 6 possible outcomes, which are 1, 2, 3, 4, 5 or 6. Probability of independent events. If 2 events are independent, the outcome of one event does not affect the outcome of the other, then the probability of both events occurring is probability of both events equals probability of event A times probability of event B. For example, the probability of flipping a coin and getting heads twice in a row is 1/2 times 1/2 equals 1/4. Because the probability of getting heads on the first flip is 1/2 and the probability of getting heads on the second flip is also 1/2. Probability of dependent events. If 2 events are dependent, the outcome of one event affects the outcome of the other. The probability of both events occurring is probability of both events equals probability of event A times probability of event B. Given that event A has occurred. For example, the probability of drawing 2 cards from a deck without replacement and getting 2 aces is 4/25 times 3/51. Because the probability of drawing an ace on the first draw is 4/52 and the probability of drawing an ace on the second draw, given that an ace was already drawn, is 3/51. Missing probabilities. To find missing probabilities, you need to use the information you have and apply the laws of probabilities. Here are some steps to follow. Identify what is being asked and what information is given. This could involve identifying the event and the probability that is missing. Depending on the problem, you may need to use one or more of the following laws of probability. The probability of the union of 2 events is the sum of their individual probabilities minus the probability of their intersection. The probability of the intersection of 2 independent events is the product of their individual probabilities. The probability of an event A, given that another event B has occurred, is equal to the probability of the intersection of A and B divided by the probability of B. Use the information and laws of probability to solve for the missing probability. Make sure that your answer makes sense in the context of the problem and that it is between 0 and 1. Worked example. The table shows the probabilities that a biased dice will land on 2, on 3, on 4, on 5 and on 6. A table is drawn. Namer rolls the biased dice 200 times. Work out an estimate for the total number of times that dice will land on 1 or on 3. Use the fact that the total of all probabilities must sum to 1. Let's say the missing probability is x, then x plus sum of all the probabilities is equal to 1. Now solve it for x. So x equals 1 minus 0.69 equals 0.31. The probability of landing on 1 or on 3 is the sum of the probability of landing on 1 and the probability of landing on 3. To estimate the total number of times the dice will land on 1 or on 3, multiply it by the number of times the dice rolled. So 200 times 0.31 plus 0.18 equals 98. Examination tips. Probabilities can only be expressed as fractions, decimals, or percentages. Fractions are typically the best when there is no format specified in the question.